Okay. Today we position SmartDO as an AI-powered and multidisciplinary and multiphysics smart design solution. So I'm going to show you some first some brief history and the product profile, and then today I think most of the simulation software, engineering simulation software, they have their own optimization package. Then
Yes.
why the customer bother to buy another general purpose optimization package? So it's very important that we need to know what's the unique competitive edge of SmartDO and why is SmartDO so powerful. So customer is willing to buy it, and also a lot of software partnership with this big software company. Why they are willing to do that? Yeah, that's very important.
Yeah.
And then I will tell you some successful story and customers, and then we can talk about some business value to the customers, because today when the big corporation they want to buy the software, probably they are not only focusing on the technology level or like how useful it is. Sometimes the engineer have to say what's the business value to the customer, and to SmartDO is very straightforward. And if you are interested, later we can talk about our technology breakthrough, especially mathematics. But I think today we won't talk about this. After you review this and you digest all, if you are interested, we can talk about this later. And also where to find more information about SmartDO. Okay, the SmartDO, the development history of SmartDO begins in 1992. So even if you look into the whole world, this optimizer has a very long history. 1992 is when I studied my MS degree in ASU, and it is continuing to improve and develop. So the first commercial version of SmartDO is released in 2006. And if you consider, commercial version, SmartDO is have very long history too. If in the whole world, I would say today, this kind of general purpose optimization software, probably only less than package still operating. And this 5 package, some of them I think is almost dying too. Most of them are merged by big software company. And so even if in the commercial version, SmartDO is pretty old. I will say it has pretty long history. Yeah. And our company reorg 2009 to fully focus on SmartDO. In the beginning, our company focused on simulation, engineering simulation consulting, and we did that for a long time. And in 2009, I decided to reorganize company. We fully focus on SmartDO. And now today we have so many software partners. For example, the big names like SolidWorks, LSTC, Hexagon. Hexagon is MC Software. MC Software is purchased by Cadence again. And ANSYS today is merged by Synopsys. Yeah. And Beta CAE. Beta CAE is an European company. It purchased by, I think, Cadence. And JMAG is a Japanese electromagnetic company. They mainly focus on motor. And Siemens, yeah, another big name. Okay, today's SmartDO has so many different modules, as you can see. We have a direct link to this software. And between this software, we have some way to link them to. But the data stream between any two software is not ready yet. For example, you want to pick an ANSYS link with JMAG Designer, the mechanism is already there, but the data stream, like you want to migrate the electromagnetic force or to mechanical force of answers. That had to be done some customization, or you have to do some your own program, something like that. But most of the time, if we figure out that need is very popular by customer, yeah, and all this together, you can link them, cross-link together by what we call the universal smart link. And if
Yep.
we don't have the smart link, what does smart link mean? I will show you later. We have a direct link of database between SmartDO and all this package. And if we don't have this smart link, direct link, we have this universal. What is universal connection? As long as your software has a text file input, text file output, and I can call your software from command line batch mode. That's it. You can link with it, and it's linked by GUI. You don't have to do any scripting or programming or customization either. Yeah.
Okay. I would have to go and how that's used, universal connections.
Yes.
So that basically allows you to link to most softwares, most industry softwares.
Yeah, I think this is quite enough already. So in the
Okay.
short time, we don't have a lot of plan to expand to other software. For market,
That's
yeah,
okay.
for market reason, if you cannot sell this, sell others. Yeah, and
Yeah.
we have limited manpower. And later I will
Okay.
talk about one newest module we call OpenSync. We will focus on this for the next, I think, 5 years, 10 years, something like that.
Mm.
OpenSync
Yeah.
is the module you can link to open source simulation software.
Right. Right.
Yeah, so it's like when you buy SmartDO, if you don't have a simulation software, finance software, finally to OpenSync. It's like you buy SmartDO, you get a free structure or CFD software. Yeah, I will talk about this later. We put
Okay.
a lot of hope on this module, and we publish it in 2024 in our conference. And before it is published, already 3 customers, say they want it. So it's very popular.
Okay.
Okay, what's the unique competitive edge of SmartDO? It's very important. Because let me tell you, if you want to write a general or very, well, how do I say that, not so powerful optimizer, if you are a good programmer, probably you only take 20 to 50 line of codes, you can write it.
Mm.
Okay, so what about SmartDO? Okay, first, SmartDO is what we call the one-page setup GUI. We pack everything in one page. It's very simple. The catch is you have to have a very stable and very reliable parametric model for your finite software or your simulation model. The programming skill and technology progress a lot. For example, if you are writing your software or your program, you must know that you can ask AI to write a lot of script or code for you. For me, now on about 60% of the coding job, I let AI do it for me. It's very simple.
Mm.
But have a GUI is whether your software can solve this problem, that's another story. So SmartDO is what we call a push button automated design optimization
Yep.
technology. I will talk about this later in detail, and we even have number to show it. And that number is not only by experience, it's by mathematics, it's starting mathematics. That
Yeah.
some rule you cannot break. It's like some rule of the nature rule. Okay, third, SmartDO has been successful with problem with 240 plus design variables. You probably have don't have a good idea about what does this mean. Later, I will show you too how much calculation time it will need for this kind of problem.
Isn't those like points where you can actually like redefine the configuration? Like you can redefine 240 points, I guess.
Yeah, it's like when you are doing a design, there are always some parameter you have to change
Yeah.
or you have to modify to satisfy your requirement. For example,
Yeah.
you probably have to change your shape of a
Right.
part, right? Then it will satisfy your stress must be little than some allowable stress, or your displacement must be little than some allowable displacement, something like that.
Mm.
And you must have
Yeah.
some goal, because if you want the part or structure to be strong enough, for example, you can just boost the whole weight. It's always
Okay.
very easy to satisfy everything. But you always want to, for example, minimize the weight. Like, you have to satisfy a lot of stress constraint, displacement constraint, but you also want to have a minimal weight. And there are something always you have to adjust. For example, the thickness of a shell or the shape of a hole, something like that. That's called design variable.
Yeah.
And you have so many design variables, and the problem become more and more complicated. And SmartDO has been successful in 240. If you look at the paper, from 1970, I remember the biggest problem has been solved is about 100 design variable, and that's
Mm.
experimental. And this one is a industrial real case. Yeah. Uh,
Okay.
and also we have more than 200 successful story across different industry. Why is this so important? Because we are selling in engineering software anyway. In mathematics, you always can show how sound your formulation is and which formulation you are based. But people will always ask, do you have some real world example? For example, today there are still a lot of innovative finite element software. It uses very new technologies and looks promising. It's really looking promising. But if they cannot show real example to the customer, then it's very difficult for them to sell. It's very difficult for the customer to accept too. And I can tell you, for the examples from our customer gave us, which we can show. This does not include something that our customer don't want to show. We have
Mm.
more than 200 successful stories, and each stories we have very precise improvement about what SmartDO have done. For example, how many percentage of the objective it has reduced or improved, or how and the calculation time it takes, something like that. It's very precise. If you look at other optimization software successful example, they always say something like, okay, our customer like it, they help them improve a lot of time, but they seldom show you what's the real result. And something very important is we will always show how many design variables in this model. Yeah, so you can just compare with their experience. Most of the time when you have many design variable, for example, 10, 20, is considered a lot today.
Mm.
When we show the result, customer will always ask, how is that impossible? How you do that? Yeah. But it's very important that you have some real case, because you
Yeah.
can always make up some simple example, and like what we say the demo case or Mickey Mouse case, and you show them that it's very fast. It is common in software industry. People always do that, But when you have real case, then the customer will begin to see, okay, this is real, something serious.
Right.
Okay.
So, can I ask you a quick question regarding the variables? You mentioned that SmartDO can support like 240 plus variables, right?
Okay. Yeah.
So it's probably the most powerful optimizer to date, from my understanding.
I would like to say that, but
Okay.
yeah, I would like to say that, but you never know. You never know. But from
Mm.
our point of view, I will say yes. Of course, each
Okay.
optimizer has its specialty. You have to say that
Mm.
because different
Okay.
method, right? Different approaches. They have
Yeah.
different purpose. But if they are using the same approach as us, I will dare to say yes. We are probably the most powerful optimizer on earth. Yeah, and that's our
And
goal
I
too.
guess,
Yeah, that's our goal too.
right.
And
So we have like
if you focus on
competitors.
certain purpose, for example, want to get the optimal result and quicker, I will say
Mm.
that we can beat everyone too.
Okay.
Yeah.
So our main competitors are like Ansys, Altair, Siemens, um,
Yes. Yes.
the Salt System, S-Teco, and there's a lot of.
Yes.
So, okay.
Yeah.
Um,
Especially the big software company like Ansys, they have their own optimization, right? Siemens has it, and Altair
right.
has it too. Altair actually their most powerful tool in the beginning is optimization tool, but now they are
Okay.
not focusing on this a lot.
Yeah.
And
Right.
what's so powerful about this software company? Let me tell you a case. For example, the customer already have Ansys, and his first choice, of course, is an optimizer from Ansys too, right?
Yeah.
And not to say the habit of the customer, the sales channel, everything, they have all the advantage. But
Mm.
what's their disadvantage? Usually this software, they stop to support other software. For example, Ansys optimizer RPCN, it used to support a lot of different software like us. But now they already close most of the link to other software, or the link is still there, but it's not maintained anymore. And you can understand that too, because they want to have the closed system. They want their customer to use everything from their system, right? So this is their disadvantage.
Okay. Okay. Understood.
Yeah, what happened
And
is
you said our competitors, they typically can't surpass 100 design variables.
no, they I even never see something like a 10 design variable.
Okay, even 10, they can't really.
Yeah, I can show you why later, because it's a
Okay.
mathematical rule you cannot break. Yeah.
Mm.
Yeah. So in addition to the traditional method, why is SmartDO so powerful? Because in the old time, we already imposed a lot of the AI concept and algorithm into our mathematical formulation. And the result, why we have to do that? For example, most of the approach we are using is called the gradient-based or differentiable approach. As you may know that for gradient-based, you can only find the local minima, but you can find relative global optima. And another very important functionality is, for example, you are doing optimization. You have to repeatedly change your CAD, right, or change your model. And at some
Yeah.
point, your model may break. It will stop working. For example, you have a plate and you have a hole inside, and you make the hole bigger and bigger, then the plate will become unbuildable by the CAD. it will stop. And 100% of the software today, optimization software, you have to stop and fix your model. That's very painful. And if it does not fix, it just ignore those data. Okay, this is a very big problem for doing design optimization. But in SmartDO, starting point is successful. If it can encounter some fail point, failed design, either is a broken CAD or is unconverged FEA model or something like that. It will try to learn from this data and avoid this unsuccessful design. So it's very convenient. That's why you can just push button and just let it go. And third, is something we call the multi-objective optimization. In mathematics today, you can only handle one objective. Human beings just not able to handle multiple objective functions simultaneously. But we have some breakthrough in mathematics, so we can handle multiple objectives and each one directly. In optimization, you usually have different number of parameters in scale. For example, your force may be 1 to the power of 4, and your thickness may be just 0.001. This will always cause problem in your optimizer and your numerical iteration. SmartDO will do automatic scaling, so you don't have to worry about this. All these different technology in SmartDO, actually each one we can probably write several journal papers about this, but we choose not to publish. Okay, and another one very important is your controlling parameter. If you have ever doing any nonlinear problem simulation or calculation, it always has a lot of controlling parameter, and it's painful. And when your software say it has some smart option, in the old day when I was in Honeywell, I always say when software say they have a smart option, they must be doing something stupid. Because what they do is they just some preset condition, like you say this is 1, this is 2, this pair me to the 0.01, 0.02, something like that. But it cannot be used for all cases. SmartDO will try to its calculation history and adjust the parameter by itself. Okay. So the result is, as I say in the beginning, is a multidisciplinary and multiphysics automatic design optimization software. Okay, if you compare SmartDO to other optimization software, we can probably summarize them by these two pictures. For example, this is a traditional optimization software. Actually, this feature was get from one of our competitor about 10-15 years ago. This is how they show they do optimization, and in the middle, of course, they put their software, and then we take it out. We replace by traditional optimization. In traditional optimization, you have the initial design, then you have to scatter some sampling point. You do some sensitivity study, and from the fitting function, you approximate an optima, and it's a local optima. Then you do some study, plotting, statistic, and guessing, something like that. You get your final design. And SmartDO is like you have initial design, you couple SmartDO with your simulation model, one push button, it will get then you get your final design. It's very fast. And the most important, you don't have to worry about doing this all day. For example, I have the experience too. I believe you have too. Doing a simulation model is already exhausting enough, right? You put 1 day, 2 days, just try to fix the model, fix your parametric model so it's stable and accurate. Then you have to spend about the same amount of time by your hand, adjusting different parameters, reading the report, analyzing the data. That's just not a way to do engineering. Our goal is that as long as your simulation model is ready and stable, you will spend minimal time on setting up SmartDO, and you will spend minimal of your time manually to do adjustment on SmartDO. Okay, let's see. What do we do on traditional design iteration? Usually we have some parameter, right? Probably it will change, decide your thickness, your size, your shape of your model, and then you calculate by computer program. It will give you some cost performance index, constraint like stress, temperature, flow rate, or your electromagnetic field, something like that. And we engineers there do some guessing, and our best experience try to change the parameter, calculate again, and try to guess if this is the best one. Before we have optimization, or even today, I think 90% of the design they call optimize. It's not really an optimize. It's just that you cannot improve anymore. And that's a difference with Artima, because Artima solution has a very strong definition in mathematics. Okay, later human beings learn to do something more advanced. That's what we call the traditional design exploration approach. You still have some parameter to adjust, and you have to do some calculation. And what do a lot of they scatter a lot of sampling point, like randomly, or some we call the ad hoc rule. They do statistic, then do approximation, and use graphic, try to figure out what's happening, what's the best solution there. For example, they do some sampling here and try to fit the function, and they will approximate the optima here. Okay, the problem with this is you are not really getting the real optima. It's just statistic, and it's just approximation. And second, it need a lot of calculation time. If you notice, I keep on mentioning calculation time. I'm going to give you some real example very soon. SmartDO, what SmartDO do is it change your design parameter, read your performance index, and try to do iteration by yourself, totally automatic. And as I just said, today the programming technology has improved a lot. So for any problem, or if you want to write a general purpose, this kind of process is not difficult. It's really not difficult. Of course, how you design your GUI and the process is another thing. But writing software is not so difficult today. But that's what we call the brute force approach. You can always link them together and just calculate and try and try and try. Okay, let's see why we call SmartDO a one-page setup interface. This is a page where SmartDO will set up its optimizer parameter. Want to do some nonlinear structural analysis, you always has a lot of to adjust. What's the approach, convergence tolerance, spatial scheme, something like that. In SmartDO, if you open the optimizer parameter setup, you have two to choose. First one we call gradient based, which is differentiable. And if it's not differentiable, other one is discrete solver. And I think most engineers understand what is differentiable, what is not differentiable. So it's easy to choose. And from our experience, most of the 99% of engineering problem, you can always adjust it to differential problem. Okay, here is the option of our optimizer. We have a lot of optimizer, but you always pick up the default. It's all set up as a default. And what are these for? Some are then for educational comparison or for historical reason. We just present.
Okay.
Yeah. For example,
So
some of the teachers, they may want the student to try different optimizer or software to see what's the difference.
so actually the SMDS, that's SMDS1 and SMDS2, right? Version 2.
Yeah, yeah.
The most optimal selection over
No,
here.
the version 2 is the experimental optimizer. That means we are
Okay.
still
Oh, okay.
experimenting. Yeah,
So different. Okay.
yeah. Usually we won't suggest user to use it. So only when this problem is really strange and we don't know what happened, we will say, okay, try this. But after a
Okay.
while, after we have improved this, while we think it's stable, it will be put here. So it's painless to the customer. They just use the default. Yeah, we always, the customer, they want to try their own setting. We don't suggest. The most important is uh, first, SmartDO has a parameter calculation mechanism. It's very stable. Second, most of the time, no matter what you adjust, will try to uh, calculate its own parameter inside. Yeah. Okay, then there's one option called smart learning. What's smart learning? During design optimization, you have a lot of iteration. You produce a lot of calculation result, and these results should be reused, and that's what we are doing. Every time we try to do one new simulation, we will look back to the history to see if there are some data to collect, to interpolate, to extrapolate like this. And this is very useful. And it's set as a default too. And you see, most of the optimization calculation time is spent on your simulation calculation time. For example, your FEA, your CFD. So in the optimization world, its computing efficiency is usually measured by how many times you have to call your simulation software. And we will see that later. And this one, to force Vmax to be little than 0, what does that mean? In optimization, you will always have some problem because in nonlinear simulation or nonlinear analysis, you always have tolerance. For example, you say my stress has to be little, right? And from theory and numerical analysis, 100.01 probably is considered converged already, or 100.0001, something like that. But we know in engineering, you always have to push the value under the tolerance, right? If you have a report, your specification say your stress must be little than 100. And you give the report that my stress is 100.01. You say this is just 0.01 is okay. No, it's not okay, right? So it's always a big problem. And SmartDO don't have that problem now. By satisfied before, it will push your constraint to be exactly or even more less than your allowable value. Very difficult to do. Yeah, it's very difficult to, even in mathematics or programming. And third one is what we call the safe. What I just say, you can try to avoid the fail cat or fail model. And then you set up how many design variable you have, how many constraints you have, and how many objective value you have. That's all for you setting up the optimizer parameters in SmartDO. And here has the option for restart. For example, you because the optimization always takes some time. For example, before you leave the office, you let it run. And second day you come into office, it's still running. You can stop it and do your job. And before you leave your office, you can restart it again. Yeah. Okay, then sometimes in SmartDO you have to pick the location of your CAD or simulation software. This is for SmartDO to call, of course. For example, you want to pick you want to use SolidWorks, you also want to use Siemens Sim Center 3D, then of course you have to tell SmartDO what's the location of this program. But once you set up, SmartDO will remember it. Next time you open or on the same computer, and if you have new version, you just assign again. Okay, and this is a real setup page of SmartDO. Let me explain what's it. For example, you have a CAD, you have a simulation model. Of course, you have to tell SmartDO what's the location of those models, right? And then you just tell SmartDO you have 6 design variables. Okay, SmartDO will read in your model, list all the parameter from your model, like here. Then it will pull down menu to select which parameter you want to match with the design variable on SmartDO. For example, you have 6, so you have to match 6 parameter. And this parameter, of course, is an input parameter. It must be adjustable. Yeah. Yeah. And then you set up the lower bound, upper bound, and initial value. These design variable. And I have to emphasize the lower bound and upper bound is very important. This is up to the engineer, up to the user to decide, because in design, at least you need to know how large your parameter can be adjusted, right? You have to have some basic idea. Then objective. You maximize the objective. And the same, you can pull down any parameter from your software, match with the objective of SmartDO. And then you most probably have some constraint. You have to little than some value, you have to greater than some value, something like that. Okay, I have to mention here in SmartDO, constraint is something it try to satisfy first, and then it will try to improve your objective as much as possible. This is like our engineering design. For example, of course, we always want our structure to be as light as possible, right? But first, you have to satisfy your stress constraint, displacement constraint, stiffness constraint. So in engineering, we always try to find a feasible design that satisfies all requirements first. Then we try to improve it, right? So sometimes, most of the time, by satisfying all the requirements is difficult enough. Okay, this is what we call a one-page setup. After you set up this, you just write SmartDO model, let it begin to run. And let's see these two. This is almost all default. This is something you just have to do. This is a main setting up page of SmartDO. That's why we call it one-page setup. And what's the difference in other optimization software? For example, all this they have also different optimizers, and even if they use their support or your developer, which optimizer I should use, they will say, probably you try that, you try something like that, and after you done the optimization, you not find anything good, and ask them again. They will say, okay, this is the button here. You push it, then you can adjust all the parameter, and you can try all different parameter. It's like a infinite loop. It's a unlimited path. In SmartDO, you can see you don't have to do that. It's very intuitive. It's easy to set up. Okay, as I just say, it's easy to have the software linking everything together. And of course, design your GUI is another story, but the most important is how you do the calculation. Remember, we are here to find optimal design automatically, not to do brute force approach. SmartDO is not a brute force approach. It does not need pre-train historical data. It will generate and explorating data on the fly. Let's see example. If we have n design variable, SmartDO probably need 20 times n your simulation software to evaluate. For traditional software, for example, something we call design experience response service, to get a simple response to be useful, you need at least 3 to the power of n. Why? Because each variable, if you want to do quadratic fit, right, you will need at least 3 points. That's reasonable, right? And for n design variable, you will need 3 to the power of the n. And this is only a quadratic fit. If you have a case like this, okay, here, it's not enough. It's far from enough. So this is just a basic evaluation. Of course, they will say, okay, you can evaluate less point and do some interpolation. But when you get less point to fit, you will get very inaccurate result. And for AI, AI is easy about AI today. AI, you need a massive amount of historical data. So let's just take example of 10 design variables for the second order design experiment or full rank response service quadratic fit. You need about 60,000 evaluation of your simulation model. Consider that if you each you take about 40 days. Yeah, and we know 1 minute is usually not enough for one simulation. For SmartDO, it will take about 200 times to call your simulation software to evaluate. And if each time take 1 minute, it's about 3.3 hours. And AI, as I say, is massive amount. Okay, so you can see the difference. You will see 200 calculation is a lot, right? Then you should consider how about 60,000 times. Yeah. So there's a difference. This is a mathematical rule you cannot break. If somebody tell you they can just use 10 point to predict any problem and get a optimal design, you probably want to ask him if he has done something magic about the mathematics or he has invented something like that. I think we all learned this in our junior high school. You need 3 point at least to approximate or to fit a quadratic function, right? And if they can use 2 point to fit a quadratic function, you have to think what happened inside. Okay, SmartDO usually always get better. This is what we can promise. In the beginning of SmartDO, we do a lot of head-to-head comparison with other software. Our customer will do that, and almost 90% of the time, we always get better results. And one thing very important, especially in today's world, we support open source simulation software. As I show you here is a module we call OpenSim. And OpenSim, we try to couple with as many open source simulation software as we can. Of course, before we support it, we spend a lot of money and time try to evaluate, try to test it, and sometimes we even try to put money and resources to improve it. So this has spent a lot of resources to it. Another one is very you may want to know that a lot of our customers, they will try to do their customization and put their own button on SmartDO like this. Yeah, like Teco is already doing this right now. Okay, I just talked about OpenSim. It's a cross-linking platform for open source and commercial simulation software. For example, it's always okay to use open source simulation software because you just want to get a useful design, right? Useful analysis. And I can tell you that today's open source FEA solver is very stable and accurate. For SmartDO now we support Prepomax. Prepomax is open source pre and post processing software for finite element, and it supports the open source software calculus. And the next version, it will support Abacus. Abacus commercial software is very popular. Yeah, and we funded this coding. And on the CAD, is currently OpenSea supports three kind of CAD. FreeCAD is open source, and SolidWorks and NX. Why do we have to support the link between the commercial CAD and the open source finite element software? As I say, in finite element software, as long as you can verify your result, people don't worry about a lot what kind of software you use, even if it's open source. And we are gradually building up the verification and validation result for calculus too. The so far result show it's stable. There's no problem about it at all. Actually, it has been used for about 20 years, so it must be stable. And for CAD, it's different story because commercial CAD, they have their own standard, and you cannot just give an open source CAD format to your customer or something like that. So it's very important. And we will build up this support on commercial CAD later, more and more. And here we will build up more. For example, next version in 2026, we are already working on it. SmartDO will support one open source CFD software. And later, we will try to link the CFD software to a structured software. For example, the pressure you get from your CFD software should be able to link to your, finite element structural analysis software. Then you can do something like multiphysics. And the most important thing, these are all free and open source. So you will ask, why SmartDO has to do this? How do you get money from this? We get money from first the linking module. Customer has to buy it. Second is the optimization platform always. And from this optimization platform, the customer can use TK as a programming language. It can use Python as a programming language, and Python will link to a lot of free AI module. And the data between different language, TK and Python, they can be exchanged, and they will be streamlined. So it's like you can call your Python in your TK in SmartDO. Okay, this is a new capability since I think 2 years ago. This is very powerful for our for our customer and for us too. As I say, we have mixed language scripting, and if you are interested in this, we can talk about this later. Yeah. And the data stream between SmartDO, TK, and Python is automatic. Yeah, this is most important. If you look at the most software, if they have scripting language, if they have more than one, it's very difficult for them to pass the parameter from this one to that one. In SmartDO, it's automated. And also you can install your own Python and your own add-on module. In SmartDO, you can assign if you want to use the Python in SmartDO or you want to use the Python in your own computer. Why is this so important? Because today, most simulation software will support some scripting language, and the most popular one is Python today. And the problem with that is their Python is what we call a closed environment. First, usually you cannot add more module into their Python. For example, Python today has the module you want to use, usually is not possible. First, the version is fixed. But in SmartDO it's different. You can use Python in SmartDO. You can point the Python to your own Python. It's like SmartDO have the linking module with any Python you want to link. It's the same concept as SmartLink. In Python, there's infinity possibility. You can do scientific or numerical calculation. You can do AI statistic and plotting. For example, this picture is plotted by Python. Actually, at least in Taiwan, a lot of customer is already replacing their MATLAB with Python. Yeah. Okay, so for SmartDO, your interface, or you want to link with SmartDO to your own simulation software, you have 3 different level of linking. First is smart linking. Smart linking is what I just showed you, something like this. Yeah. Okay. And second is what we call universal connection. I will show you later. And then is scripting, and you can combine all them together. Yeah. So for this mechanism or an architecture, we will say SmartDO probably can link 99% of the software on Earth right now. Yeah. Okay, look at the successful story. As I just say, we had more than 200 design variable successful model, more than 200 successful stories. Okay, in Taiwan, just in Taiwan, SmartDO has been applied in major engineering project. In this major engineering project, first one is in the nuclear power plant, structural optimization and reliable optimization. And the power company, they have a thermal power plant, and they use it for the automated design system of their turbine and their water pump blade and rotor. A military vehicle, military aircraft, and actually many years ago, Taiwan has a missile. Some accident happened, and it hit some shipping boat, and at that point, the whole world understands. My God, Taiwan has this kind of a missile, and that missile is optimized by SmartDO. Yeah. And military aircraft, and Taiwan has our own satellite too. Structure is optimized by SmartDO too, and other kind of big structure and big engineering project. Okay, that is some small example I show you. And how about in different field and physics? SmartDO 9 has at least example for 18 different fields. So if you or your customer want to see if SmartDO can do this, probably you want to look at this table first to see if which one fit your need. For example, fan and turbine blade, connector, both mechanical and electrical, and semiconductor. As you may all know, the semiconductor is very important industry in Taiwan. Composite material and flow paste like nozzle and ejector, and automotive industrial and topology optimization, steel structure, or any general purpose lightweight structure, heating, cooling, machine tools, and you want to integrate and automate your own digital production line, like your CAD, CAE, your own software, and electrical motor, speaker, medical, optical, and electromagnetic interference, and all open source simulation software linking. Okay. So far, we have these big companies to be our customer. Of course, we have others, but some of them are not willing to reveal their name, and some of them probably not so big, but these are the big names. For example, Intel, TSMC, ASE, or all this, Delta, something like that. And I have this. Where is TASA? Oh, I did
So
not.
I have a quick
Yes.
question. So with regards when you perform like optimization for, let's say, um like a building, you don't really try to optimize the foundational structure. It's more of like the top side. Is
Yes,
that
yes.
okay?
It usually
So we can
depends
apply
on,
that to ships as well.
yeah, sure.
Focus
You
on
know,
areas that are
as I
not fundamental. Yeah.
say, as long as you can parameterize your model, your simulation model, you can always optimize it. No matter it's the thickness, the size, the shape, or something like that. And if you have some criteria like stress, or even or in a building is more even more complicated because you have to consider earthquake, right? And
Right, right.
yeah, as I say, we have optimized several buildings in Taiwan, and those buildings has been in service for about, now it's a kind of about 15 years already, I think. Yeah, and each one reduce weight by our 15% in average. Yeah. Okay, what's our business value? This is very important. From our experience, this is from our customer. If they can really merge SmartDO into their standard process of design, do it every day, gradually will increase product performance by about 10% in average. 10% may not look very large, but in engineering, in real world industry, it's a lot. 10% means everything. Yeah. What's the
Yeah.
chance of you seeing 10% improvement in your life less time? Probably never. Yeah. Only when something happen, like you change your uh, ship, the shell of your ship from steel from composite, right? You probably has a lot of improvement, but for engineering improvement, it's very difficult. And you will save up to 2/3 of your design cycle time. Why? This a lot of people always ask why. Because when you are when you leave your company, when you leave your office, SmartDO is still working for you, and it is doing something smart, not just doing something brute force. So if you have some design iteration, we always encourage our customer, do it before you leave the company, you leave the office. It's very important because why? You only work in the office about 8 hours a day. Normally, I know a lot. All of us have overtime all the time, but normally you work, 8 hours a day, but you have 24 hours a day. And how about in the weekend, right? So especially in today's world, we all know the working force is more and more difficult to find. So it will be very uh, important for the manager and the executive level of the company. And you can accumulate in-house knowledge into system. You can do some customization. You can code your knowledge into it. And most important with SmartDO, it's not only just verification, standard criteria. You can do automatic design optimization. And that's most important. You can use SmartDO as a smart design platform for all the everything. As long as you can parameterize it, as I just said, and you want to fit into different package process into SmartDO, we have so many different level of ways to do it. Yeah. Okay, so that's it so far. The
Yeah, I think
introduction of
that's
Smart.
great.
Yeah. So I'm
Right.
wondering if you have
So
any question. Yeah, we can discuss.
yes, sir. So I do understand like just the generals, like just introduction about SmartDO and all its capabilities. Um I'm just wondering, what industry does most of your what industry does your application mainly support in Taiwan?
Okay. I think the industry in Taiwan is a little similar to industry in Korea, because
Yes.
we have
Okay.
almost everything. Yeah, and
Yeah.
in Taiwan, you only have few big company, and you have a lot of small company doing everything. So, if you ask me what kind of industry you support, let me show you again. I mean, not just support, already our customer.
Because, honestly, I do see a lot of opportunities in the shipbuilding industry, but
Yes.
the issue is, it's kind of risky because, like Howard and I, we're both working under American Bureau of Shipping, right? So it's kind
Yes.
of like a conflict of interest. Um, so in this case, company is probably gonna, let us go if they find out.
Yeah, sure,
So we're
sure,
trying to,
sure. You
yeah,
always
we're
you
trying
have
to tap,
be Yeah, you have always have to be careful about that. But there are something you can do a lot. Yeah, actually, if you talk about industry, for example, the rotor machinery, right? This is fan and turbine.
right?
This is very big in America, especially. Yeah, and
Okay.
the connector. This I don't think there's a lot of company doing connector in America because it's too small. Semiconductor, semiconductor probably, for example, Korea. I think a lot of Korea company will be eager to understand what TSMC is doing, and we know
Yeah.
that, and we know
Mm.
that, yeah. And the composite probably not a lot in Taiwan, but we have like what composite industry do in Taiwan. In, for example, bicycle, some ship, small ship, like
Yeah.
a golf club, something like that. Okay. This is like something, this kind of thing is very small part. And car wheel, I don't think American is doing car wheel anymore either. But you can
Mm.
see it cover almost all different kind of industry. And as you just say, as you say last time, you didn't see a lot of systematic product here, right? It's true. It's true. Yeah, let me show you. For example, for lightweight structure. Structure is more, you can see more systematic systematic product here. If you talk about lightweight structure, for example, nuclear, defense, rotor machinery, and aerospace, something like that. Yeah, yeah. This is what we call the AM of the armored vehicle. Yeah, so
Mm.
it's yeah. And this is a facility in the nuclear power plant. You can see it
Yeah.
reduce yeah, like this.
Mm.
Okay, this is another one. From my understanding, this was cargo deck. Actually, it came from U.S. Air Force. Yeah, they outsourcing. They also is in some company in Taiwan, and the Taiwan company asked us to optimize it. Yeah, this was a long
Okay.
time ago, almost 15, 17 years ago. This
Yes.
this almost 20 years ago. As you can see, we have
Mm.
been doing this a lot. We have
Right.
been doing this advanced job when other company are doing, they don't know what they are doing, right? Today, even
Mm.
today, they cannot achieve something like this. Yeah,
Yeah.
and this is another, yeah, this car wheel ring. You can see, you just begin from some very conceptual model here.
Mm.
And SmartDO can change it from final design like this. This company doing a lot of advanced car wheel like sport car. They only do
Mm.
high-end car wheel. Yeah, this is another one. This is
Okay.
something very interesting. This is from my PhD thesis. That
Mm.
time we have local pioneer. All they do is pre-build roof They want the system. They input everything, and they want the computer program to figure out what's the optimal design, something like this. Yeah, my advisor told me this story. I have no way to verify it, but he said after they have this company begin to buy all other similar company in US in Arizona, and later it even begin to buy all the this kind of company in US. Yeah, this from the turbine rotor. This is a satellite. This satellite is set to launch in USA by I think next month or so. It's what we call a Formoset 8. They use SmartDO to optimize the structure of this optical lens. Okay, reduced by 20 kilograms. Save fuel cost about US dollar 1.3 million. So this is our royal user. I think they have a
Yeah.
3-seater SmartDO
So
inside. Yeah.
so they bought the software for, let's say, like 50K, and they were able to save fuel costs by 1.3 million. It's almost 26-fold
Yeah.
cost savings.
Yeah.
Okay.
So they love us a lot. They have a lot of lab. Nobody can come in. I can just step in and they will show me the tool or something like that. Yeah.
Okay. So how were you able to calculate the fuel cost savings? Did you have to do your
Oh,
own research, or
okay.
was
No,
some data
it's very
provided to you?
simple. For example, they want the satellite to be launched by SpaceX, right? SpaceX just have the money for them. Each kilogram, it will cost how much? Yeah.
Okay, okay.
Yeah.
So it's a simple calculation. Okay,
Yeah. Yeah.
understood.
Yeah.
Awesome.